The next thing that we want to talk about is how we can take all the information we've created in Mastercam and create some machine-readable code. Your file where you can open the supplied file MCU2D-mil generate NC. In the toolpath manager, we're going to start by selecting our toolpath group, and inside the top of the manager next to our simulator options, we have post selected operations. If we go to our machine tab, we also have G1 generate, which allows us to post the code. So these are both the same exact option, just different ways to access the tool. We're going to left click on it and note that we have some post-processing options. First off, it asks us to output part file descriptor. It asks us for the NC file, and we're going to set it to ask. And then it has NCI here. So these are all various options that we can change, and in our case, we want to make sure that we have NC file selected, ask for the file name, and the edit box checked, which will open up the default post-processor code editor, which is going to be Code Expert. We're going to say OK. It'll ask us for the file name and location that we want to save it, and then we'll say save. At this point in time, it's converting everything that we've done inside of our machine group. All the toolpaths we created are essentially telling the tool exactly where it needs to go, and then Mastercam is generating the code that the machine will read based on that information. Now this is important because the machine that we select needs to be appropriate for what the physical machine is. The controller might need to see very specific code in order to work. Now that we have the code editor open, let's just expand it really quickly. We want to make sure that we understand all the ins and outs and intricacies that we have inside of the Mastercam Code Expert. Now I do want to note that this is not the only code editor that you can use. This just happens to be the default one with Mastercam. So if you're used to using a different code editor, you can set it up in Mastercam, and that way you can edit the code in something you're familiar with. But for our purposes, let's take a look at this default install and see what information we have in here. The first thing that I want to note is that the file is color-coded. Anything that is a comment is shown in green. And comments are shown based on the text settings of our post-processor. So in our case, it shows the date, it shows the file name and location, it shows the material selection, and it shows all the tools that are needed, as well as the order they're used in. So it starts with tool number 10, which is flat mill, and you'll notice there's also a note next to it that says stock to leave 0.05 and stock to leave in Z is 0. So it even gives us additional information with that tool about what it was used for. In this case, we know that it was used for roughing because it's leaving stock on the wall. As we go down, you can see that comments that are inside of each operation are shown again in green. And these are comments that we specifically entered when we were setting up each toolpath. As we go down a bit further, we'll start to notice that other things are color-coded. The Z coordinates are in bold red, and you'll notice that we have positive and negative values. Our X's are highlighted in blue, the Y's are in brown, and we actually have our G value, G1, G2, and so on, are in a lighter green than we see in our comments. We also have other things color-coded like this A0 because our post-processor in this case actually had a fourth axis. So it's telling us that the A value is 0, and it tells us that we have our M code as well as our spindle speed, and all the other different things that we would need to find in our code quickly are all color-coded for us. As we scroll down through this file, this first operation is dynamic, so it's going to take quite a while. But as we get to other operations, we will see other comments start to pop up, and we'll just scroll down closer to the end. You can see that we have a tap operation. It's using tool number 8, and we have a pectoral operation using tool number 7. So these are all things that are very easy to see just graphically from a visual level, just looking at the code. Even if you don't specifically know exactly what each G code is doing, G43, G99, G83, and so on, you can quickly see what operation we're dealing with, what tool we're dealing with, as well as the coordinate system. The next thing I want to talk about is the option at the bottom here called Find Extents. What this will do is it actually goes through the code and it finds the minimum and maximum travel in each X, Y, and Z. Also note that it is listing A, B, and C because some post-processors will contain information to control those rotational axes. In our case, we can see that the maximum Z value is ½ inch positive, so ½ inch above our part, and the maximum negative value, or the minimum value, is minus 1.7963. So this is also great information. It tells us how much travel we're going to need in the Z direction. We can see how much travel we need in the X and the Y as well. So it's all really good information for us to know just from running it through CodeExpert. There are also other options, and again, we have this similar tab interface that we're seeing across the board. We have a home section, a view, and an NC function section. The home section gives us options to do find and replace, things that you would find in normal text editors. We also have a file compare option. We can launch an application. We can multi-stream. This allows us to launch multiple views because we can open multiple NC files in here. We can have one displayed on the left and the right. We have some NC configuration options, which will launch the NC configuration editor. So if we select that, you can see that we have a configuration for our Fanuc mill. We also have specific options inside of here for how comments are handled, some of the utilities, the block numbering scheme, fonts and colors. And again, these are all very specific to this post. So we can modify those by going into that NC configuration. And there's also a reload with encoding. It goes back and it reloads it with specific encoders. The View tab is, again, just very basic in terms of what we can do in terms of changing the look of what we see on the screen, tiling it horizontally or saving that and also resetting it back to stock. And then in the NC functions, this is where we really start to get into some and do manual edits, such as adding our own code. If we have to manually put a stop in the program for some reason. Paths. Now the best option is to go back to Mastercam and actually modify those parameters on the tool. But again, and these are all traditional code editor type functions. So marking, going to the next, or if we're directly connected to a machine, we can send it from the CodeExpert or directly from Mastercam to the machine. So if you are using the Mastercam CodeExpert, there's lots of functionality in here that you can play with and lots of different color coding techniques. Aspects like the XYZ coordinate system, the tool changes, and the comments. I do also want to note that the order is based on the order of operations inside of our toolpath manager. So our peck drill and our tapping operations were the last. You order these toolpaths. It's a good idea to do it back in Mastercam by simply dragging and. So if we decide, for example, the tracing operation needs to happen before, we can simply drag it up and reorient them inside of our toolpath manager. And then if there's any, we can rebuild those and make sure that everything, including the stock. So that's my recommendation to you, is to make sure that you do as much as you can in Mastercam in the CodeExpert in order to modify and edit the code. So from here, we've covered pretty much everything across the board. Mastercam's interface, from setting up a program, from Mastercam design tools, understanding how we deal with levels, geometry and solids, and then we got into programming the part with some basics and dynamic toolpath motions, and talked about radial chip thinning and all the things. Then we did our drilling application. We drilled all milling options that we have, like helical and circular. It's talking about how to verify, backplot, and use the simulator. This is about where we're at the end of the course. So hopefully you guys in Mastercam 2020, but make sure that you don't up here. functionality in 3-axis toolpaths, multi-axis toolpaths. It goes on from there. So thanks again for learning Mastercam 2020.